All right, guys, so let's move on to another theory class on flow control. And I'll show you some new nodes now. We'll carry on with the rest that we've got set up here. So just so we can understand a bit more about the process behind what these nodes can do. So I picked a couple of examples for you here that'll be useful for us and just put them in comments to make it easier. So what we're going to look at now, well, let me show you this one that's called do n and do once. Okay, so they're similar, but I'm going to show you both at the same time. So for programmers, this is used quite often actually, these nodes here. And even for those who use 3ds Max scripts as well, do n is a node that's used quite a lot. But it's a lot easier for us to take it in through Blueprint, okay, rather than looking at text. Basically, it executes a function n times. So do something n times, it means. That's basically what this is saying. So there's going to be a flow coming in and going out. And here we can tell it here or through variables what we want it to do. So we can tell it how many times it should execute an action. Okay? So do n a number of times. So it's going to execute at the moment 10 functions and it will show through the print string. And just like the multi-gate, we can reset it as well. Okay? So I'll repeat whatever comes afterwards 10 times. And so by the way, just so you know, we're going to be using print strings on all of them. Okay? Just to show the effect of what it's doing. So you can have a sequence of animations, for example. You know, it could be anything you're choosing to animate, and then it can execute them from here. And no matter how big it is, from this point onwards, it will execute the function a number of times, however many times that you decide in that node. Okay, so let's do something here. Let's use our event tick and plug it into do n. So it's working according to the number of frames. In other words, here it's going to enter. Every time something comes in, I'm adding the event tick, okay? So I could use an event such as when you push a button. So it'll just do it once, or just hold the button. If you press it again, it's going to execute the number of times it's shown here. And I'm setting it up for to use the event tick. And what I can do here is add a delay just so it's not showing everything too fast. And let's use a delay of 0.8 seconds. There we go. Great. So as it comes in, it's going to meet the event tick and come out and go into the print string. And then I'll connect it to here. So it writes on the screen, do n. And here we have the node for the counter. It counts the number, right? So I'm just going to make that visible as well by plugging it in here, just so we can see it on the screen. There we go. That'll be useful for us. I can't see where you might decide to use this at the moment, but you know, you might be able to think of some examples, maybe in some games. Okay. But it's good to understand the principle behind this node. Maybe in a game perhaps that fires bullets, you know, it might be necessary to count the number of bullets, for example. Okay. Right. So take that as an example. If you shoot, it's going to execute the shooting function, right? And here it will have that function that represents shooting and the sound and the bullet coming out and everything else. And it's going to count one by one. So what can you do with this? Well, you can make an inventory when the bullet cartridge is running low, for example. So you can have a variable here that counts every time one unit is taken from the inventory. So it's going to work out that calculation of what you got at the beginning and -1 each time something is fired. And then you can reset it here if you want to once the cartridge is being reloaded. Maybe that's an example of how and where you might use a do n. But clearly not an example that you would use in ArcViz unless maybe there's another example that you can think of. Having said that, a lot of these actually do have a place in ArcViz, and you might find that just on the rare occasion you do need to use a do n. So that at least now we've shown you, or we are showing you how they work. I'll leave these here at 10, plug in the reset with the G key. So when I press G, it's going to reset. Let's push play just so we can see how it's running. You see that? So it's going to count to 10, then it's going to stop. And if I press G again, it should reset and start again, right? Okay. Well, it looks like the gate's showing up here as well. I need to remember always to disable the functions before we do these tests. That will help. But every time I press G, it's going to reset the counting, okay? So this is what it's doing. Let's just unplug this. We don't need that. Just so it's not confusing us. Okay, so that's what it's doing. It's quite a nice node, quite sophisticated really, isn't it? But we'll need to find a use for that maybe later on. And what about the do once? Well, the do once is this one here. It's like the do n, but slightly different. It's only executed once, as the name suggests. So the entry is here, and you can put in the exit as well. So basically, it just does something once rather than a continuous amount of times. Let's move on to the next one. Now, this is a really, really good one, and you might find a use for it in ArcViz. I'll show you though what it does, just so we understand. For loop is what it's called. And it does what the name suggests. It does a loop. So for example, if I push the G key, it's going to start the loop. Okay. And this loop, there is a loop for this first index into the last index from 0 to 10. So it'll execute 1, 2, 3, all the way up to 10. And what does it execute? What is the loop body? Well, it will execute whatever comes after this. So it will add this. If I add this here, it's going to loop what comes after. Okay. So I've added the print string, but you could add many different things here after that, just so we can see it on screen. I'm using the print strings. So this is the index here, and it's going into a print string as well. So it's going to tell us what's being counted, and we can run that one. There's a little difference though, that there's a node here called completed. So to end it all, I can say done. Okay, so I can link that to there. And so it's going to do this loop with specific counting or whatever you decide to put here. So let's show this on screen so you can get an idea of how it looks. Okay, let's press play. So if I run the loop body 0 and loop body 1, actually, let me just increase that. Let's try 10. So just on the screen for a bit longer. Let's try again. Let's press the G key. Okay, so you can see it from the bottom to the top. Loop body 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we couldn't see the end of the loop. So let me just reduce this. Oops. Let's go back a bit. There we go. Right, so let me just see if I can just change it to 5. So it's a little lower. So it's gone from 0 to 5, and then it's added an end loop. So why is the end loop disappearing? Well, that's because the time here is also lower. I set it up to 10, didn't I? So let's try again. 0 to 5, and then the end loop. So if I push this, it's executed this number of times, and it's doing the loop. Okay. Over here, this is called our for loop. It's a variation of it, which is called the for loop with break, which is the exact same thing, but I can add a break to it. So I can add a key here or an event or something, and then that's going to activate the break. So if this is being executed and you want the loop to stop for some reason before it's done, you can add a function that stops it. Which is pretty simple, right? Okay. So we don't need to demonstrate that. It's just the same thing with a break in the middle. Cool. Let's move on then to the next node. So now let's talk about while loop. That's what it's called, while loop. Actually, before we do that, let's talk about operators. Actually, that'll make more sense. Now, we saw mathematical operations back in the beginning with variables when we looked at that. But we only showed you the operations. Okay, so let's show you a little bit more detail here, because we only showed you the operations of addition, subtraction, multiplication, etc. However, there are comparison operations. Now it does it between two values, which is really cool. I'll show you some nodes as an example. So the ones we have are basically these. Then I'll show you an example of one of them. Now it will tell you if they're equal or if they're not. It'll give you back a Boolean which says if it's true or if it's false. This doesn't execute a calculation. It won't give you a value, but it will give you a condition because they're being compared. So let's suppose that our character has maybe 10 stamina bars as an example. And as you get hit, this value then would decrease, wouldn't it? And this is just an example, but it could be any example where this is used. But when does the stamina bar come down to 0? When the character dies. So if I added the value of the character's stamina here, and the second variable is 0, if it's at 1 or 10, the value won't be equal. So it will tell us that it's false. Once it hits 0, then it becomes true. So from the moment it becomes true, it then executes a routine through the program that kills the character. So he's still alive between 1 and 10. That's always false. When it becomes 0, it's true. Okay, but that's just one example. Basically, that's what it does. It compares and gives us the answer true or false. This is the equal with an exclamation mark. So it compares values and tells you if they're equal, and then it will say they're true or false. Pretty similar to the one above. But this one compares if the values are not equal. Okay. This is the mathematics sign for more than. So it compares if A is more than B. It tells you if it's true or false. And this is more than equal. Do you remember your math classes? Your inequality classes? So more than or equal. And this one here is the opposite. This is less than as well. Less than equal. So there are the 6 different conditional or comparison nodes that we have. We have the mathematical operations for adding, subtracting, and here we have the comparison operations, which will always give you like a Boolean variable in the pin saying true or false. And this is used to analyze conditions. All right. Now let's go to the next flow called a control node called while. Now let's look at while loop. Cool. So what happens here? Well, this is the while loop. It's a node that's like our for loop. And it means that while the condition is true, then this loop will still run. Okay. However, when it's false, it's going to stop running. Okay. So what could it be useful for? Maybe the motion of something on the screen. So maybe something that's always in loop. So if you push a button, for example, maybe then it stops working. So the condition is that when the button is being pushed, the true condition will be the only condition that will stop it. Okay, so let me show you step by step. So at the beginning here, when I press the G key, it's going to start the loop. Then there's a loop body, which executes a loop body function. Then there's this completed node here too. Okay. So we can use a completed node. Once it's done, it's going to end the loop. And I'll change this to 10 because I think it would be too short otherwise. And now this is where the most interesting part comes in. I've created an integer type variable. So the integer variables here, which are whole numbers, if you remember from our previous classes. So the integer here being at 1, or value of 12, I'll compare it if it's different from 2 as well. So if 1 is different from 2, it will show me the condition being true and the loop will keep running. Now when this becomes equal, it will become false. So if 12 equals 12, then this is false. And this function will stop the loop, right? I'll start at 2, but but I have to increase these until it gets to 12. Otherwise, it'll be like this all the time. So what do I have to do? Well, I've created our first set here, our set node, the one that we've seen before. I'm just setting up an integer one, and I've added an integer one here. So every time this is executed, it's integer of +1 here, integer +1. So it won't be 2. Next time it'll be 3, 4, 5 until it gets to 12. And when it gets to 12, it's going to stop. So let's see what happens. Let's push play. And I need to use the G key to generate this. Okay, let me just adjust it to 8. So our integer 1 starts at 8. Press the G key. How many loop bodies do I have? 1, 2, 3, 4. From 8 to 12, there's 4. So it starts from 8, then 9, then 10, then 11. Or no, it was already at 8, 9, 10, 11, 12. So you got the idea, right? It runs in a loop until a certain condition becomes true. And when that condition is fake, it stops the loop. Okay? So this is it, really. This is obviously a theory class, but there are only these two concepts here that we're focusing on. Nothing practical except from our print strings. However, we've hopefully shown you the background of how it all works, just so it doesn't become too complex when we go further on. If you aren't too sure about any of the concepts we've gone over, then just rewind and watch them again, or ask us any questions that you have. So we'll finish this theory class here. The next class will work with our ArcViz blueprints. Okay.